Okay, let's try some of this first type of vector addition. This is the simplest type we have. It's when we're solving for perpendicular vectors. That means they're only north, south, east, or west, or 0, 90, 180, and 270 degrees. The very first step is to redraw these head to tail. I fight with physics students all the time about the importance of redrawing these vectors, but it really helps you with visualization, and at this point it's less important, but if you're getting good habits now, it'll make your life easier when these get harder, and they're going to get harder. So the first step is to redraw them head to tail. That means you should be able to draw them together without picking up your pen or pencil. I like to start with the x vector first because that tends to make putting your final answer in unit circle easier. So when I redraw these, I get 2, and then head to tail, so the head of this arrow to the tail of the next. And that gives us that our answer, our resulting vector, is going to be there. And that makes sense. If we looked at it this way and tried to draw it, it could either be going that way, northwest, or this way, southeast, which doesn't make sense if we have a north and east. We know that that should go this way. So in order to make that into a right triangle, we have to redraw them head to tail. And we always put our theta where the resulting vector starts, so between it and the x. This means that this is our adjacent and this is our opposite. And we want to know the hypotenuse and we want to know theta. And now this looks just like a problem we did a few pages ago when we practiced trig ratios. It's this setup that's the new step. So in order to find theta, we would do, if we looked at our trig ratios, we have O and A, and I suggest using tangent, though you could find the hypotenuse first and then use it. But again, if you made a mistake once, then you've made the mistake twice. So we have tangent of theta equals opposite over adjacent. So the tangent of theta is equal to 3. And when we take the inverse of that, we get that theta is 72 degrees. And if we think about reality, if this side is so much shorter than this side, then it would be a large angle, wouldn't it? And then to find the hypotenuse, we would do the Pythagorean theorem, a squared plus b squared equals c squared. So we have 2 squared plus 6 squared. So c squared equals 40. But don't say the answer is 40. You've got to take the square root of it to get c. So you get that c is 6.32. So you would tell me that the resultant vector So now we have these two pieces of information and we need to make sure that our theta is in unit circle, because I want the answer you give for the resultant vector, you could give it to 10 people that understand unit circle, and they could all draw the exact same line, going the exact same direction, just based off of your answer. So we have to make sure it's in unit circle. Look at this one here, our drawing here, and I can kind of sketch the unit circle on, and I picked red so it wouldn't be so hard to see the difference. And we want the angle between 0 and our resultant vector, and in this case our theta is our answer in unit circle as well, but it's not always going to be true. So our answer would be 6.32 at 72 degrees. So I should be able to give that to anyone, and they should be able to visualize or draw the same line, going in the exact same direction.